In this video I'm going to be taking a look at linear approximation. We're going to start with the definition and then we're going to use linear approximation to find a decimal approximation for an expression, and we're going to do this without a calculator. So this is just one example. I'm going to do my example of just one way to use linear approximation, but there are a multitude of ways to do it, and I will address some of those other ways in a different video. But first here, let's take a look at just like a general definition of what linear approximation is. Okay, so let's consider a function f that is differentiable at c. Alright, the equation of the tangent line at c is given by y equals f of c plus f prime of c times x minus c. Okay, so this is going to be the equation of the tangent line at c. Alright, it's called the tangent line approximation, it's called the linear approximation, lots of different verbiage that can go along with this, but it's just a different way to write that tangent line approximation. Alright, now the values of y can be used to approximate the values of the function f at c as x approaches c, because that's what our tangent line does. Okay, now if we want to use this to just find a decimal representation of some expression, and we don't have a calculator, then we can do that. Okay, so that's what I'm going to focus on in this video. Alright, maybe the directions are going to tell you to use a linear approximation to find the value of the expression, square root of 50. Alright, now naturally what we would want to do is just grab a calculator, put square root of 50 in and get the decimal. Okay, however, trying to connect what we can do here, alright, if we think of this linear approximation as the equation of that tangent line, if I can come up with a function and I can let a value x approach c, then I can use those values of y to approximate this function. Okay, so basically, let's see, what do we got here? We've got square root of 50. Alright, so we can't do square root of 50 in our head, but we could do square root of 49, and 49 is really, really close to 50. Alright, so we want to pick, if we're trying to do this to come up with a decimal approximation here, we want to pick the closest value we can to 50 that's going to be a perfect square root that we're going to be able to work with here. Alright, in which case then I'm going to let my c equal 49, because I can calculate the square root of 49. Alright, now can I look at this and figure out what my function is? Well, my function is going to be the square root function. I'm just specifically here taking the square root of 50. But really, my f of x is just the general function here is the square root of x. And it's the square root of x when x equals 50. So I've got an x value, I've got my c value. Now I can put into play that linear approximation formula. Okay, so let's go ahead and write that down. Where shall we do it? Let's do it over here somewhere. Let's do y equals f of c plus f prime of c times x minus c. Okay, so there's my formula that I'm going to be working on here. Alright, now basically, you just have to go through and think about what you need. I need f of c, I need f prime of c, I need an x minus c. Alright, so my c value is 49, I need f of c. Alright, so if I calculate f of c, alright, here let's be a little bit detailed here. So c equals 49, I need to calculate f of 49. Alright, well, if I plug f of 49 in, my function is square root of 49, that's going to be square root of 49, which we know is equal to 7. Alright, so if I start filling in what I know here, y equals, I've got a 7 so far. Alright, now I need the derivative at c, so I'm going to take my function, calculate the derivative. Let's try to be organized here. Alright, so f of x equals square root of x, alright, which if I rewrite so that I can see that a little bit better, that really is going to be an x to the 1/2 power. Alright, let's go and calculate that derivative. Alright, it's going to be a nice little power rule there, so I'm going to have a 1/2 x to the minus 1/2. Okay, go ahead and move that to the denominator. I'm going to have a 1 over 2 square root of x. Okay, so now I've got my derivative. Okay, so now I can find my derivative at c. My c value is 49, so basically all I have to do is plug 49 in there. So let's be a little more organized here. So f prime of 49. I'm going to plug it into that first derivative, so 1 over 2 times the square root of 49. All right, again, we're doing this, so it's values that I can do in my head. So now I'm going to have a 1 over 2 times the 7, which is a 1 over 14. So that f prime of c value is 1 over 14. And I'm going to be taking that times the quantity x minus c. Well, we said our x was 50, so 50 minus c is 49. Alright, so if I simplify this out, 50 minus 49 is just going to be a 1. 7 plus 1 over 14, y equals 7 and 1/14. We might as well just leave it right there. Alright, so what I can conclude from this is now I've used this linear approximation. I have found this, if I turned it into a decimal, would be the decimal approximation for that. So I've got the square root of 50 is approximately equal to 7 and 1 over 14. Alright, and then if you need verification or proof, alright, go ahead, pause the video, take square root of 50 in your calculator, get that decimal, and then turn 1 over 14 into a decimal. It'll be 7 point something, 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 and it's going to be really, really close. This is giving us an approximate value. I used that tangent line approximation. Alright, I looked at this, came up with my function, came up with a value. So as x is approaching c with this, then it will allow me to calculate this decimal approximation. Alright, now like I said, this is just one use of this linear approximation formula. Alright, but a lot of textbooks have you start with this idea and play with this idea a little bit before you actually put it into play with some story problems. So definitely thanks for watching, and be sure and subscribe to the channel. Thanks.